Hey everybody, what is up? Hope you're having a wonderful day today. Today, we are going to be learning about human impact on the environment. We are going to talk about some of the different things that humans do as they interact with the different parts of the environment. And we're going to talk about some of the consequences we have because of that behavior. So let's jump into it. First off, how many people? Well, when we think about the world, we have to talk about the number of people who are using the resources. So we need to define what a population is. So a population is all of the members of a species living in a given area. And the human population has increased over time. If you take a look at this graph, you can see we've had a significant increase in population starting in about 1950. And the reason for that is we have a longer life expectancy because we're becoming smarter. We learn more about what it takes to survive, and we have better advances in medical technology. And so you can see our population has increased significantly over the past 50 years or so. We are up to almost 8 billion people in the world now. So with that being said, we have a limited number of resources. There's only so many resources to go around for all the people. And so as we continue to grow our population, it becomes concerning that we won't have enough resources. Now, if you take a look at this graph here, this is just a simple representation of the amount of calories that are available for people to consume. So a really basic need is food. Okay, that's one of our resources that we use on a daily basis. And you can see in some countries, the ones that are dark blue, like the United States, we have a surplus of calories. We have over 4,000 calories per day per person if we wanted to. Now, there's other countries on this map. If you see some that are like a lighter green, a lot of countries in Africa are in the lighter greens, as well as a couple countries in South America. They have a limited number of resources for food. So it's going to be more difficult for the people who are living there to survive based on the amount of food that is available for them to eat. So is there enough for everyone? That's the big question. Can we really support 8 billion people? Carrying capacity is the largest number of individuals of a given species that Earth's resources can support and maintain for a long period of time. So when we think about all the people on Earth, we have 7.8 billion people on Earth using these resources to meet their daily needs. And it's not equally distributed. So this is our fossil fuel consumption. Remember our basic fossil fuels, we have coal, we have crude oil, and we have natural gas. And this is where it is used based on the countries around the world. Now you can see the United States is, once again, a very dark brown. That means we are using the most fossil fuels compared to the rest of the world. Now, we are one of the higher ones. You can see China is actually the darkest brown. They use the most. Now, that has to do with their population being so huge as well. But you can see throughout the world, it's not equal. Africa especially stands out because there's not much color on that map in Africa. That means they're not using many fossil fuels, okay? And that has to do with their ability to maintain those fuels, but also just their lifestyle to be able to travel and to heat homes and things like that. It's very minimal in those countries. And so as you look around the world, it's not an equal distribution of resources, and that's concerning because our population is also not equally distributed. But places like the United States, even though our population is not huge, we still use a ton of the resources. So what about the trees? That's one of our main resources that we use for a variety of different things. And we use that for different paper products. We use it for building homes. We use it for creating furniture. We're chopping those trees down. So deforestation is the removal of large areas of forest for human purposes. Deforestation destroys habitats, which can lead to species extinction. So this is the map of forest covered in 2020 around the world. And you can see, once again, it's not equal. Okay, lots of trees in different places. You look at South America. South America is one of the biggest spots where deforestation occurs because they are so heavily forested. Now, once again, if I pull you out of here, deforestation destroys habitats, which can lead to species extinction. So that can destroy the habitat of different organisms, and then they're not able to thrive and reproduce. And a lot of the times we lose different organisms, not just animals, plants, things that could be cures for different diseases, those medicines within those plants, we lose those because of deforestation. Now, there's some other negative impacts of deforestation as well. The removal of trees leads to an increase in carbon dioxide in the atmosphere. And if we look at photosynthesis, remember just the basic process is photosynthesis. The leaves take in CO2, that's carbon dioxide from the air, and then they use that CO2 and they transform that into oxygen and sugar, and they release that. And so the trees are taking in carbon dioxide, which is what we exhale, and they're putting out oxygen, which is what we inhale to survive. And so if you keep on removing the trees, we're going to run out of oxygen and we're not going to have as much of the carbon dioxide taken out of the air. Deforestation can also lead to poor soil quality. If you pull all these trees out of the ground, there's no longer anything holding the dirt in place and there's no longer nutrients in there being absorbed. And so the soil can be negatively affected as well. Now, I know some of you guys learn a little bit better when you can see a video and see kind of visual proof. So we're going to jump into this video about deforestation for a couple minutes, and you're going to see this impact that we have by kind of knocking down all these trees. So check this out.
Forests cover about 30% of the planet, and the ecosystems they create play an essential role in supporting life on Earth. But deforestation is clearing Earth's forests on a massive scale, and at the current rate of destruction, the world's rainforests could completely disappear within 100 years. Why should we care about deforestation? Together, forestry and agriculture are responsible for 24% of greenhouse gas emissions, making deforestation a significant contributor to climate change. Deforestation impacts the amount of greenhouse gases in the atmosphere in two ways. First, when trees are felled, they release the carbon they are storing into the atmosphere. Second, trees play a critical role in absorbing the greenhouse gases that fuel global warming. Fewer forests mean larger amounts of greenhouse gases entering the atmosphere and increased speed and severity of global warming. In addition to helping regulate the Earth's climate, forests provide habitats for over 80% of the plants and animals that live on land. But deforestation destroys these habitats, diminishing biodiversity. Some estimate that 4,000 to 6,000 rainforest species go extinct each year. This also affects the more than 2 billion people who rely on forests as sources of food and shelter. The biggest driver of deforestation is agriculture. Farmers chop down trees in order to plant crops like soybeans, palm trees, and cocoa, or to make room to raise livestock for beef. Logging operations, which provide the world's wood and paper products, also cut countless trees each year. Forests are also destroyed as a result of growing urban sprawl as land is developed for dwellings. The effects of deforestation are grave, but not irreversible. Efforts such as managing forest resources, eliminating clear-cutting, and planting new trees to replace those removed are already being made to reduce deforestation's environmental impact on our planet. And while some plant and animal species are gone forever, combating deforestation can help prevent further loss of biodiversity.
All right, guys, so you can see deforestation is a pretty big problem. Okay, we rely on our forests for a lot of different things, and if we continue to take away from that, we're going to have a problem. The challenge is, with all our population increasing in the world so much, we have more needs for all those products that we get from the forest, so we have to try to find a balance somewhere. So that's deforestation and the way we affect kind of the land. So now let's talk about water. Water everywhere. Most of the Earth's surface is covered with water. You guys have all seen pictures of the globe and the world, and it's a large portion of water. So where is the water? Well, a total of 3% of the Earth's water is fresh water. That's not much because we have so much water, you'd think, why would we ever have to worry about it? But only 3% is fresh water. Most of the fresh water on Earth is trapped in glaciers and polar ice caps. So if you look at this chart, 71% of the Earth's surface is covered in water. but only 2.5%, 3% rounded up, fresh water is available. And most of that is locked up in ice caps in polar regions. So the readily available fresh water is only 1%. That's the fresh water we use to shower, to drink, to wash our hands. All of our daily needs are met with only that 1%. You can understand why that could be a problem with our increase in population. So we have all this extra water. We know about the water cycle, and the water continuously replaces itself through that different process of evaporation, condensation, and precipitation. But sometimes we get extra water, and that's when runoff occurs. Water can flow across the land. So if the water does not absorb into the ground, it puddles up and then it goes across the land. Now, once it goes across the land, water flows across lawns and farmland, picking up pesticides, herbicides, and fertilizers. So all these chemicals that we put on our different land to prevent bugs or to make it grow faster, that gets into our water and contaminates our water source. And so now that once was fresh water is now contaminated, and we can't use that. We have to clean that in order for it to be usable again. And you can see here, this is some of that runoff just going into a reservoir where it's stored. But you can see that is far from being clean, fresh water. That has picked up a lot of chemicals from that land where it washed over. So that's water. Let's talk about the last type of impact we have, and that's the air. The air up there. The atmosphere is the layer of gases that surrounds the Earth. And the ozone layer is part of that atmosphere, and that's the layer that prevents most harmful ultraviolet radiation from reaching the Earth. Those are the bad rays of the sun that can cause problems for humans if that hits us. The use of chlorofluorocarbons caused the ozone layer to become thinner. So these chlorofluorocarbons, or CFCs as they're called, those were really, really popular in different products back in the 1970s and 80s. And like different refrigerators had it for cooling, different aerosol cans like spray cans would have it. And scientists figured out those are causing a lot of harm to our ozone layer. So in 1971, you can see it was pretty clear that it was green and covered. That's the view kind of from up top. But as the amount of ozone was depleted, you can see that's the red line, that's the total ozone, it's going down. In 1971, it was close to 300 Dobson units, just a measure of the ozone. But by 2000, you can see it's almost down to 150, almost cut in half. And so what we've done is we've passed different laws and legislations about using those CFCs, and those are not allowed anymore. And so the hope is by 2065, we start to rebuild that ozone, and it gets better and better as we continue to monitor which type of products we're using. Because if we don't have the ozone, we have a lot of harmful sun rays coming through, and that's going to cause a lot of problems. And so our last part is still dealing with the atmosphere a little bit, the impact of automobiles and power plants. Photochemical smog is formed when sunlight reacts with waste gases from burning fossil fuels. Now, you guys have probably all seen smog before, and that's our picture on the left. But that comes when the sun reacts with the waste gases from burning fossil fuels. So in other words, when we're burning coal and crude oil and natural gas, when that goes up into the air, that reacts with the sunlight, and that produces our smog. We also have another negative impact on the environment with acid precipitation. And that forms when waste gases from automobiles and power plants combine with moisture in the atmosphere. So once again, here's our smog. You guys have all seen pictures of this before. But basically, it's just showing the atmosphere is being polluted with the waste gases from us burning those fossil fuels. And then acid precipitation is very, very similar, except instead of mixing with the light and undergoing that reaction, it's mixing with the water in the air or the water vapor in the air. And then that combines with those water molecules and falls back to Earth. But it's got those different chemicals in it, like that sulfur dioxide and nitrogen oxide. And that actually falls down on plants and can kill them. Now, it's not acid precipitation like going to put a hole in your skin, but it's polluted water. And when that falls on plants, instead of them getting their normal, healthy, fresh water, they're taking in that polluted water, and that acid rain or acid precipitation can lead to a lot of problems. All right, guys, so when we think about the environment, I want you to remember three things. I want you to remember that we impact the land by deforestation. We impact the water because we only have 3% of it is available as fresh water. And then we also impact the atmosphere by burning different fossil fuels, and those gases react with different things within the atmosphere to cause some problems. All right, guys, that's all we have for today. I hope you have a wonderful rest of your day, and I will see you next time.